Alright, let's start right into it with lesson 6.2. I would like to ask you to take your books to page 411 to 417. As we do, you'll notice that this is an introduction to a new concept. It's called the law of cosines. Last time we learned the law of sines, and so this time we want to look at the law of cosines. I want to go through this briefly so that you can get up to the board and do as many problems as possible in a little bit of time. And so you'll notice here the two cases remain. So last time we talked about side-side angle, and we were able to use the law of sines to find any piece of a triangle as long as we had a certain amount of them. Specifically, we're dealing with oblique triangles, those that do not have a right angle in them. So two cases remain: the side-side-side, where you have three sides given and no angles, and then the side-angle side, where there is an angle between two sides. You'll see here I have a picture of a triangle drawn here. And you'll see if you're given side-side-side or side-angle side, the law of sines would not work. So here's a triangle. Look at this one with me. And you'll notice side A is 8, side C is 14, and B is 19. If we set up the law of sines so that we can find the angles, none of the proportions turn out right. You can't actually finish these problems. If you knew one angle, you could. So that leaves us with a new need. We need to learn a new law. This particular one is the law of cosines. So we're going to slide down here and look at it. Now, at first glance, just because there's letters everywhere, it is a scary looking one. My opinion and my suggestion for you is to look at this bottom left one here, and I would memorize this one. The reason I would is that it's c squared equals a squared plus b squared. You've already memorized that. That is the Pythagorean theorem. Works for right triangles. What we do after that, this next portion, is we add minus 2ab cosine of c. And then you'll notice that these are pattern based. So it is whatever you're solving for is equal to the other two sides squared minus 2 times that side and that side and the cosine of whatever angle you're let's try that again. Whatever angle you're trying to find. Okay? So let me try to show you the pattern with a new one. If we're solving for a squared then, now you can see it off to the left, but if we're solving for a squared, then we're going to use the other two. So it would be b squared plus c squared minus then 2, and I'm going to take these two squared values, b and c, b, c, and the cosine of whatever I'm solving for, a in this case. And then the last one then is b squared. B squared is equal to the other two, so a squared plus c squared minus 2ac, those two there, and the cosine of b. So it's a pattern recognition. Now, in your book they call these ones on the left the standard form. I honestly, that's the one I use almost all the time when I do these problems. Over here you have the alternative form. That would be one that is already solved for C. Okay, so notice in doing these problems, you're always going to do the math. The math actually isn't too bad. The hardest part's memorizing the formula. But at the very end, if you want to solve for C, you'll have to take the square root of both sides. So let's look at a problem where we use this new formula to solve a triangle. Well, here's example 1. We have three sides, so this is a side-side-side case, and you have 8 feet, 14 feet, and 19 feet. Now I put this in large letters. This is page 411. Note, it is suggested that we find the angle opposite the longest side first. What this does is it helps us to prevent serious problems in the future of this. So you'll notice B is opposite 19, and 19 is the largest side, so we will be looking for B, angle B, first. So here's what we're going to end up doing. As we set up this problem, we can actually, it would be good for us to use that alternative form, actually. So as I look over here, if I'm looking for an angle, I'm going to go right up here to these forms. Because I'm looking for B, I'm going to set up this one. So I'm simply just going to write my form. So looking up there, but writing down here, I'm going to say cosine of B is equal to a squared plus c squared minus b squared all over 2 AC. Now, this is just solved for. I actually could easily take this one up here and rewrite it for that one. They're the same formula, just solved for cosine B. I hope that's easy for you to see. If I need to show that when I get back, I will. But it's just the same formula, it's just rewritten. You could plug all the pieces in and solve for it on your own. Either way, as you start to solve this, you're going to plug the pieces in where they need to go. For cosine b, you'll find that b is equal to, or cosine b is equal to a squared. A is 8, so 8 squared, plus c squared, which is 14 squared, minus b squared, which is 19 squared, all over 2 times 8 times 14. Okay, so you need to be able to identify what's a, b, and all that. So doing some of these here, 64 plus 196 minus 19 squared. Don't have that one memorized, so 19 squared is 361. Okay, and that is over 2 times 8, which is 16 times 14. That's a 19. Okay, that's a 14. Forgive me. Typos there. 16 times 14, then neatness matters. You got 224 at the bottom. So at the very top, you're going to have 64 plus 196. That'll give you 260 minus 361. That'll give you on top negative 101 all over 224. Well, when we do that, we will divide that by 224. We will get the number here of negative 0.45089 and a bunch of dots, because that's going to go on forever. So what we have here, and I would encourage you to keep that in your calculator for sake of not losing it. So cosine b is equal to negative 0.45089 dot dot dot. And remember, we want b. So in this case, we would take b and we would say cosine, inverse cosine of that negative 0.45089, and we'll hit this inverse button. This is the second function of cosine, and you will get that b is equal to 116.80 degrees. So I can go over here to my triangle and get 116.80 degrees as my angle b. So we're doing what we've already done. Now we have all the information we need to do further. Now, if we're going to find all the pieces of this triangle, we need to find another angle. Well, since we know now angle B and side B, we can start to use our law of sines again. So let's find C. By the way, I wanted to make a point of this. The reason we mentioned the note here, it is suggested to find the angle that's opposite the longest side first. It tells me something. It tells me that my other two angles have to be acute. Thinking about that logically, you can't have more than one obtuse angle in a triangle. And that matters because when we use the law of sines, just writing this up in the corner here, remember when we consider the all students take calculus acronym, whether or not it's true, we're still thinking about that. But we know that for a sine function, there are two places, an acute angle and an obtuse angle. So acute angle, obtuse angle, where sine would be the same number. For instance, sine of 30 is 1/2, and the sine of 150 is 1/2. And so sometimes we have to know when we use the inverse sine which one we want to consider. Well, if we're going to do this in our triangle, we're going to have to take the smaller values. So here our answers have to be acute. Let's figure out how to find them. So now that we have the B angle, what I'm going to do is I'm going to slide this down just a little bit so we can focus a little tighter. In order to find, let's just find side A. So in this case we have, since we're looking for A, I'll put sine A over 8 is equal to, and the only ratio I have is the B function. So sine of 116.80. Now it's important that you have that rounded correctly so that you can use it. Then that's over 19. Now if I multiply both sides by 8, this will give me the sine of A is equal to, and then I'm just going to take my calculator, so 116.80, take the sine of that, times 8, that gives me 7.14, and that's divided by 19. I'm going to get sine A is equal to 0.375825608. And in order to find what A is the arc sine of the above, And so A is equal to then, when I hit the inverse sine function, 22 degrees, 22.08 degrees. So A is over here, 22.08 degrees. Now the last question is, what's my third side? So when you use the law of cosines, it often requires you to get at least one angle. Notice we do the longest side first so that we can know our other ones must be the acute angles. Notice 22.08 is in fact acute. Once we use the law of cosines, we're free to go back to something we're used to, the law of sines, and use that well. Now, remember the old rule from geometry, the sum of the internal angles in a triangle add up to 180. So we have 22.08 plus 116.80. That gives me 138 so far. So A plus B equals 138.88. And so I'm going to take 138.88 and I'm going to subtract it from 180. And my final answer for angle C, and I'll write it in the blank here, is 41.12 degrees. So checking your example there, make sure that what I have is what the book says, and that is page 411, example 1. So the hardest part about this is using the law of cosines. Now, again, sometimes you'll use the alternative form, sometimes you'll use the standard form. The standard form is a lot more common, alternative form is less common. To be honest, you could write it in standard form, solve for it, and get it in alternative form. So let's look down here at 411, the checkpoint at bottom, and I'd like to do this problem with you. At the very bottom it says, find the three angles of triangle, so we're going to do the same thing, whose sides have a length of A equals 6, so A equals 6, B is equal to 8, and C is equal to 12. All right, so my question would be, if we're going to use the law of cosines, what angle would we find first? You should be saying angle C. Angle C because it is the angle opposite the longest side. So capital C, and we're going to find that first. So the law of cosines is alternative form. Again, I'll show you what I mean just real quick. You could go up here and you could find the cosine C angle, and you could just use this formula right here. It's in your book as well, but let me show you how we get that. Okay, this is the longhand version. So if we're solving for C and we're relating everything in terms of C, we're going to say C squared is equal to A squared plus B squared minus 2AB cosine C. Now if I want to find C, I'm going to solve for this portion. So what I'm going to do is I'm going to say C squared minus A squared minus B squared, okay, and that is going to equal negative 2AB cosine C. Then I'm going to divide by negative 2AB, divide by negative 2AB. Okay, in this case, when I divide by a negative, what I end up doing is I'm going to mess with all the signs. Honestly, you could write it this way. These are going to cancel, and I'm going to be left with cosine C is equal to negative C squared plus A squared plus B squared all over positive 2AB, because I've divided by the negative 1. I canceled it. So it just changed the signs of everything pretty much. Now up here, for cosine of C, you will notice the C is minused. I did it in a different order, but you would get the same exact values if you derive it yourself. So again, I'm trying to make it easy to where you only have to memorize one way. You have to do some extra work, but if all you have to do is look at a chart, all of us can do that. So again, even without drawing the picture, I know that the cosine of C is going to equal negative, parentheses, 12 squared plus A squared. A lot of these you should be writing probably already and just squaring them, but 6 squared and then 8 squared all over 2AB. Let's do that. So that's 6 times 8 is 48. 2 times that, 48, is going to be 96. Okay, and so that's where we're at. So on the top, we're going to have negative 144. Notice the negative sign's outside of the square, plus 36 plus 64 all over 96. So take a second, calculate it, figure out what's going on. So we take 36 plus 64. That'll give me 100 minus 144. Gives me negative 44, so cosine C so far is equal to negative 44 over 96. When I do that, I will get the decimal negative 0.45, and then there's going to be 8 and then 3 repeating, so I'll just go ahead and draw that there. So at that moment, I'm going to inverse cosine and find that cosine of C, actually not cosine of C, but actually the angle C, big C, is equal to 117.28 degrees, rounded to 2 decimal places. So I go over here and I say, all right, 117.28 degrees. Okay. Now the next thing I want to do is I want to think logically about my other 2 angles. If my largest side is an obtuse angle, then I need to know is are my other 2 going to be acute or obtuse? They have to be, in this case, acute, because you can't have 2 obtuse angles in a triangle. So what I'm going to do is I'm going to find B and I'm going to find A, and I'm just going to work my way backwards. Well, now that I've used the law of cosines, I'm going to use now the law of sines. So what I'm going to do is I'm going to set up sine of 117.28 all over 12, and that's going to equal the sine of B, and that is going to be equal to, or over, 8. So in this case, I'm going to multiply both sides by 8, and I'm going to get my answer. So just a quick calculator exercise here. Sine B is equal to 8 times 117 sine, so 117.28. Take the sine of it, you get 0.88 times 8, you're going to get 7.11, and then you're going to divide that by 12. The angle that you get, or the decimal that you get here, should be 0.592518185. Okay, at that point you should hit inverse sine, and it should give you the B angle. The B angle should be 36.34 degrees. So B is 36.34. And to find the last one, you simply add the other 2, these 2 over here, and you subtract them from 180. So I'm going to add 36.34 plus 117.28. That's going to give me about 153.6. I'm going to take that and add it to 180, or subtract it from 180, and I'll get my last angle to be 26.38 degrees. Now, I did some weird stuff with rounding, so you may have something slightly off from that. But that's how we do it. That's the law of cosines. So the law of cosines is used for a different scenario, but between the law of sines and cosines, you should be able to find any detail for any oblique triangle that you're solving for. Let's look at the second example, and then I'm going to let you do some problems at the board. So as we go to 412, actually one statement I wanted to make, actually. At the top of 412, your book says a statement here. Do you see why it is wise to find the largest angle first in example 1? Knowing the cosine of an angle, you can determine whether the angle is acute or obtuse. That is, and then they write some wordy things here. I'm going to go up here so we're not looking at that. But what I want to show you is that we have 2 scenarios. If cosine is positive, so cosine of B in that case that we had before, if it was positive and you take the inverse of it, so let's say it's positive 9, then if you do the inverse of that, so we do arc cosine of 0.9, okay, you will get, in this case, an acute angle. You in fact get about 25 degrees. But if it was negative, so for instance cosine of B in that last problem was, let's say, negative 0.9. Well, if I take 0.9 here, it's negative, and I take the inverse cosine of it, I get an obtuse angle. So obtuse, and that is going to be 154.16 degrees from that. Okay, so what they're saying at the top is if you find the largest angle, you can actually make a determination whether or not we're dealing with acute or not. But also, this, if cosine's positive, you get an acute. If cosine's negative, you get an obtuse. All comes from the ASTC, that thing here. All students take calculus. And so when cosine all are positive, you're going to have an acute angle. And when cosine is negative in quadrant 2, going from 180 degrees, you're going to have a negative value for cosine. So it is logical. That's something that they wanted to make a point of. So just as you see that, you want to find the correct cosine angle before you worry about finding the correct sine angle. Example 2, and this is the last one we're going to do today, is to find the last pieces of example 2. So it says find the remaining sides and angles of the triangle shown. Well, I want to find A. It just looks like I need to find it. And so setting up my law of cosines, it's A squared equals, and I'm going to give you a second to think what they would be. The other two sides are B squared plus C squared minus 2BC, the two that are squared, cosine of, and the thing we're solving for. Okay, so that's what we're doing. So A squared is equal to, and we just plug stuff in. So B is 9. Let's go ahead and just do this. 81, 9 squared, plus C squared is going to be 144, minus 2 times 9 times 12, cosine of, in this case, 25 degrees. Okay, it's that simple. Now at the end, you're going to say A is equal to, and A squared is equal to, and let's go ahead and find a number here. What I typically do is I do one each piece at a time. And so what I'm going to do here is I'm going to take 9 times 12. That's going to give me 108. I'm going to take times the cosine of 25. That's going to give me about 97 times 2. It's going to give me 195. So what I have here is 81 plus 144. Now if you've got one of those longer entry calculators, you can do this all in one step. Minus 195.762482. The calculator I have right now is reverse entry, and that makes it frustrating. So I have 81 plus 144 minus then 195.76482, and that gives me A squared equal to 29.2375. Okay, but I want A, so I'm going to obviously take the square root of both sides. We get a plus minus, reject the minus because it's the side of a triangle, take the square root of it, and you should get 5.4. And we'll call it 5.41. So after you've found side A as 5.41, the next thing you want to do is you want to try to find out what B is. In fact, it might even be wise at this point to find your largest angle. We know it is the largest angle last. We know that side is 5.41, and we're going to work our way backwards now, and we want to find out what B is. Now, we can do that by using the law of sines. And so at this case, or at this point, we can say that since we're looking for angle B, we're going to say sine of B over the 9 is equal to, and we now have a ratio of A, so we can do the sine of 25, and that is over 5.40 or 41 in this case. We'll multiply both sides by 9, and we'll get sine B is equal to, and with just a little calculation here, sine 25, we get 0.42 times 9, and we divide that by 5.41. Unrounded would be better. We find that the sine of B is equal to 0.703. Take the inverse sine of that, and we will find that sine B, actually the angle B, let's correct that for a moment. Go up here, grab the eraser. It's just angle B, not sine B. And so B is equal to, we have 44.67 degrees. Now remember, the sine could potentially give us some trouble because there are actually two angles here. So we should get about 44.67, which is fine, but we want to know, is that the correct sine? Well, if you take the sine of 44.7, you will get 0.703, which is what we have, but there's an ambiguity here. Something's not clear. So if we take 180, the supplement of this, and we take minus 44.67, we will get 135. So here's B1, and here is B2. And this is really an exercise in logic at this point. You may just get it right from the beginning. We could assume it was right, but I want to make sure you understand why we're doing this. So B could also be this, because if you take the sine of 135, you'll also get 0.703. So we know A is 5.41. We know that. And the question of the day is, what's B? Well, the easiest way to tell what B is to just try to figure out which of these B's is logical. So as we look at these together, we have 44.67, we have 135.33. Based on the way I drew the picture, it's obviously B1. But let's talk through it. Okay, if the angles we have are true, so A plus B1 then would equal, we take 25 plus that, 25 plus 44.67. That gives us about 69.67. Here's that, 69.67, which means C1 then in this case would be an angle of 110 degrees. Okay, 110.33. So if the acute angle here, B1, is correct, C would be 110 degrees. If B was the obtuse angle, then we'd have to say, well, what's A plus B? So 25 plus 135.33 gives me 160. So A plus B2 equals 160.33. That's a big one. And so from there I want to find what C would equal. Well, in this case, C would equal about 19 degrees. Okay? Obviously, this answer and all of this can't be used. C is the largest angle, and so the best one we can come up with then is that B is in fact, going up here, okay, erase that, and we can say that C is in fact 110.33. Try it. Okay, 0.33 degrees, and then the other one is in fact 44.67 degrees, so 44.67. And so we have to do a little bit of logic because we can trust our formulas. The math works, but we need to make sure we do it well. So the mathematics is clear. The only reason we have to be ambiguous is because the way that the unit circle works, sine and cosine can give us two different answers. And so we just had to be logical about which one we did. Now, you could have probably gone through this whole problem, gotten this value, gotten 44.67, and then found the C, and you wouldn't have even thought about this. But if you do potentially get something that isn't logical, that's where you need to start thinking. So for the rest of the time, I'd like to give you this, and then your proctor will assign us some homework. This section down at the bottom, this is what you all should be working on in class together. There is a solutions manual in the back if someone needs to look at that and kind of help us through it, but I will be back tomorrow to clarify. But this is the law of cosines. Make sure you know the formulas and you're ready to roll when I get back. Thank you for your attention, and I'll see you around.